So let's look at two more example problems where we have isosceles triangles and we want to use the Pythagorean theorem to find a missing side length. So we know from our previous videos, our introduction on this topic, that we have two congruent right triangles. So each of these are right angles, and this triangle and this triangle, those are both equal to each other. So because of that, that means these side lengths are equal to each other. So this is x over 2, and so is this one. And from here, we can use the Pythagorean theorem to figure out what x is. So we can choose either triangle we want. Let's just do the one on the right. So let's call this A or B. It doesn't matter. So that makes this one B. And the long side, the hypotenuse, opposite the right angle, that has to be C. So let's set up our relationship. We have that a squared, that's x over 2 squared, plus b squared, that's 2 squared, is equal to c squared. So the square root of 13 squared. Now, square roots and squares cancel each other. So this is just 13. And x over 2 times x over 2, that's just going to be x squared over 4. And 2 squared, 2 times 2 is equal to 4. So let's subtract 4 on each side. So we get that x squared over 4 is equal to 9. And we'll multiply each side of the equation by 4. So 4 times 9, that's 36. So we get x squared is 36. And lastly, we'll take a square root of each side. And we just are concerned with the positive case here. So what number multiplied by itself gives us 36? That is simply 6. So we found that this bottom side length here, this is just equal to 6, which means these are each 3. So let's do one more of these problems. And again, we need to find the value of x in this isosceles triangle. And we know it's isosceles because we have two side lengths that are equal. And actually, in this case, we have 3 equal side lengths. So this is also an equilateral triangle, where all the sides and all the angles are equal. So we know that with these triangles, when we have this vertical line here, that we get two congruent triangles, and we also know they're right triangles. So this is a right angle. And this bottom side length, this gets split in half, so each of these are going to be length 4. So we can now pick one of the triangles and set up our Pythagorean theorem. So let's maybe call this A, this can be B, and the long side is C. So that we get 4 squared, that's A squared, plus B squared, or X squared, is equal to 8 squared. So 4 squared, that's 16, plus X squared is 8 times 8 is 64. And from here, let's subtract 16 on each side. So taking away 10 goes to 54, taking away 6 goes to 48, and we can take a square root of each side. So 48, though, is not a perfect square. So with this problem, we could leave it as 48, or we can try to simplify the square root. So let's do that. So to simplify a square root, remember, we want to make a tree. So 48, that's really just 6 times 8. And 6 is really 3 times 2, whereas 8 is 2 times 4, and then 4 is 2 times 2. So 48 is really, looks like 1, 2, 3, 4 2's multiplied together, and I'm actually going to write it as 2 squared times 2 squared, since it's best to pair them up. And we have this times 3 at the end. Now we pair them so that we have perfect squares. And taking a square root of a perfect square, the square and the square root cancel out. So rewriting this, the square root of 48 is really just this product here. We have 2 squared times 3. And since we have a product, we can separate this into individual square roots. So this is the square root of 2 squared multiplied by the square root of 2 squared multiplied by root 3. And the whole purpose of pairing up these prime factors, rather than grouping them all together, is that when we have perfect squares, the square root and the square cancel. So the square root of 2 squared, or the square root of 4, is just 2. Notice square root and squared canceled each other. This is also 2, and then the square root of 3, that wasn't able to be paired up. So we can't actually find a whole number answer to this. So we're just going to leave it as the square root of 3. And 2 times 2, that's 4. So our answer in its most simplified form is 4 times by the square root of 3.